Alright, our fourth and final problem of the day is going to be another shell problem, but it is a little bit trickier. So we've got the lines y equals x and y equals 4x minus x squared about the line x equals 7. So first of all, we need to graph it, like always. So we can graph y equals x, that's pretty simple. It's just a line. 45-degree line. And now we have to graph 4x minus x squared, which if we look at this a little bit closer is we can factor an x out. This becomes x times 4 minus x. So that gives us zeros of 0 and 4 for x. So that means it crosses the axis right there and right there. So we've got some sort of parabola shape going on here. And now we need to figure out at what point these two cross as well, because we know from the past experiences that eventually we're going to need to figure out where they cross. So if we just set these two equal to each other, we have x equal 4x minus x squared. Now we subtract x to the other side, we have negative x squared plus 3x is equal to 0. Once again, we factor out x. This becomes x times negative x plus 3 equals 0. That gives us x's of 0 and 3. So we know they intersect at 0, which makes sense because it looks like they intersect there. And then this second intersection is at x equal to 3. That's a 3. Alright, so now we figured out that they intersect at 0 and 3. So now I'm going to erase this part. And we're going to, once again, look at this section but blown up a little bit. And the key other thing we need to know is that we're rotating about the line x equals 7. Alright, so now we've got something that looks, originally it looks a little bit like this, and we're rotating it over here about some other line, x equals 7, so we're going to have another straight line and then something like this. Not quite symmetric, but it's pretty close. So we're doing the shell method, so we're going to make, that's right, parallel cuts. Good, good. We're going to make little slices that are parallel to the axis of rotation. So just from these little slices, we know we have dx because it's a small change in the horizontal direction, running left and right. And now if we draw a typical cylinder, it will look something like this. And it's tough to draw in 3D. But basically we're looking at a cylinder that has a height in the y direction right here, and then a radius that runs horizontally from 7 out to here, or also from 7 back here. And the thickness we already decided was dx. So because we have dx, we know our integral is going to go from our x values of intersection, which we already decided were 0 and 3. So we're going to go from 0 to 3 of now our height. So our height, if we go back and look at just this one slice that we take, the height here is actually changing because as we move along to the right or to the left, the top of the cylinder is moving along the curve y equals 4x minus x squared, and the bottom is moving along the line y equals x. So it's a little bit different than the other problems that we've seen so far. So what we're going to do is the height is just the upper minus the lower, which we're going to just say the upper line is 4x minus x squared, and the lower line is just y equals x. So now our height is going to then be equal to 4x minus x squared, which is the upper part, minus the lower part, which is just x. So our height overall will be 3x minus x squared. Alright, and now our radius is the distance from our axis of rotation to our outside, which if we drew if we draw in our y-axis right there, I'm going to erase this bottom part. It's getting a little sloppy. So if this is our y-axis, then we have always called this distance right here x. Distance from the axis to the point on our enclosed area. And now, but we're interested in this radius, which is the distance from our slice to the line x equals 7. But we also know that this entire distance from the axis to line x equals 7 is fixed at a distance of 7. So just kind of like we did in the last problem, in order to get the radius, we take this large section that's length 7, subtract this little section that's length x, and then we get a radius of 7 minus x. So we have our radius, we have our height, we decide our width was dx, so we're ready to write that in. So our radius will become 7 minus x. Our height is going to be 3x minus x squared, and we've got dx in there. So we're in good shape now because we have dx, only x's in our integral, and it's going from 0 to 3, which are our x values of intersection. So now, the reason this is a little bit tougher is because we have to FOIL this together first, so it'll get a little ugly. This becomes 2 pi from 0 to 3. If we FOIL these through in order, we've got a negative x squared times a negative x, which will give us a positive x cubed. We've got 3x times negative x, which will give us minus 3x squared. Here we have minus x squared times 7, which will give us minus 7x squared. We also have 7 times 3x, which will give us plus 21x. And this is all dx. Alright, and now we can combine minus 3x squared and minus 7x squared to make that a minus 10x squared. So we'll do that right away. Let me know if I'm going too fast for you. So now we are ready to integrate it. So we're going to just drop that 2 pi down. Once again, we recognize we have that 0 as a lower bound, so we won't have to worry about plugging that in. Once again, it's just regular power rule that we've used. So this becomes x to the 4th over 4 minus 10 thirds x cubed plus 21x squared over 2. Evaluated from 3 to 0, but once again, 3 is the only one that's really important. So I'll plug in this 3. I'm going to erase the top part here, so if you haven't jotted this picture down, as messy as it is, make sure you do that real quick. But I'll erase this top part to begin. Leave this last part if you guys need that for the last minute or two. Okay, so now up here we still have 2 pi. Now if we plug 3 in, 3 to the 4th is going to be 243. So we have 243 over 4. 3 cubed is just 27. And actually, yeah, if we go back here, 3 to the 4th, we know 3 to the 1st is 3. 3 squared is 9. 3 cubed is 27. And 3 to the 4th is actually 81. So instead of 243 up here, it should be 81. So it's 81 over 4 minus 3 cubed is 27. And if we divide that by 3 right away, 27 divided by 3 is 9. Then we multiply it by 10. This ends up being minus 90. Now we're going to add to that 3 squared, which is 9. If we multiply that by 21, we get 191. Yep. Right? We get 21 times 9, 189, not 191. Silly. Alright. So this ends up being plus 189 over, still over 2. Alright, so now I'm going to erase the picture. And now we have dropped the 2 pi down. For your common denominator here, we've got 81 over 4 minus 360 over 4 plus 378 over 4. Alright, so we take 378 and subtract 360. It gives us only 18. Plus another 81 be 99. So we have 2 pi times 99 over 4. So finally our answer would be 198 pi over 4. Or we could have canceled this right away and just write it as 99 pi over 2. So this one was a little bit tougher, and actually in the book it only asks you to set up the integral but not evaluate it, but it's pretty simple to show that through some careful steps and just making sure we keep the algebra together that you can solve a problem like this and figure out the entire volume.